As we mentioned before, graphical procedure just work for very simple linear programming problem. The practical approach for the sensitivity analysis is to use Excel's solver add-in to generate the sensitivity report. It is easy to get the report. Just remember to select sensitivity in the report section of the solver results pop-up. This pop-up appears after configuring the solver parameters and clicking Solve button. The sensitivity report includes two tables. Let's use max and multi-max as the demo. One is for the decision variables, the quantity of max and the multi-max. The other is for the resource constraints, testing and assembly. Decision variable table shows the reduced cost. We will see what does it mean. Resource table shows the shadow price. We will see how shadow price are changed. Okay, now let's move to the Excel file to check the sensitivity report for max and the multi-max problem. Now let me show you how to get the sensitivity report through the Excel, and also how to interpret this report. Now here is the model we have set up in our last discussion, and we also find out the optimal solution using the solver. To get the sensitivity report, we still need the help of the solver. So go to the data ribbon, then click the solver. Now, don't need to change anything in your original setting, and just click the solve button. Then you're supposed to see this pop-up window. Okay, now this is the place you go to select sensitivity reports. So there are three kinds of reports. We only care about this sensitivity report. So click on the sensitivity, then press OK button. Now you will see there is a new page inserted in front. That is a sensitivity report 1. Now let's go look at it. All right, now as we mentioned in the slides, there are two tables. One is for the variable cells. The other is for the constraints. Now, if you look at this variable cells table, then it's tell you, okay, I have two variables, two changing cells. One is B14, the other is C14. B14 is for max, C14 is for multi-max. If we double check our problem setting, you will see this is exactly the case. Okay. All right. Now, then their final value. So the optimal production quantity for each computer is listed here. What else we can see? We will see reduced cost. Both of them is 0. Okay. What is the meaning of the reduced cost? So reduced cost is 0, implying that there's no need to change its objective coefficient to make its final value away from its boundary. What is the boundary for max and multi-max? We say both of them, its boundary is 0 because the boundary constraint requires both variable is non-negative, right? Okay, now, so you can see both variables, they are already positive. They are not 0. So that means I don't need to change anything in the coefficient. They are already not on the boundary. They are already positive numbers. Okay? So if max unit, then how about what? Then this column is objective coefficient. and then it's $400 for the max and $800 for the multi-max. So allowable increase, allowable decrease, what that mean? Okay, so allowable increase means both of them is with respect to the objective coefficient. So it means if max unit margin, if we increase it, so we can increase as long as we don't increase it's more than 480, so 400 plus 80. As long as we increase, the increase amount is less than 80. And if we decrease and the decrease amount is less than 200, then this optimal solution will remain. So let me magically post this notes here. Then it explains what is the reduced cost and also how this allowable increase and allowable decrease works in this table. So for the multi-max, it's exactly similar idea like what we have explained for the max. So it's reduced cost 0. That means this 0. That means we don't need to do anything on the objective coefficient. Multi-max already take a positive number, not a boundary number. And then if we want to keep this optimal solution, we can change this coefficient. Even when we change this objective coefficient, the optimal solution may still remains. So then what is the maximum amount we can increase this multi-max coefficient, and what is the maximum amount we can decrease this coefficient, this multi-max coefficient, objective coefficient. So that means if multi-max unit margin is between $660.67, so that is 800, its current margin, minus $133.33, and $1,600, that is current 800 plus the allowable increase 800. So then the optimal solution remains. So that is the idea about what indicated by the variable cells table. The second table is the constraints table. Now in the constraints table, so we can say where is the constraint, calculated constraint states. So in B18 and B19, so go back to check our model. So that's exactly what we put the calculated the consumed testing and assembly. So B18, B19. So one is for testing consumed, the other is for assembly consumed. Then their value, that means based on the current, the final value, based on the current optimal solution, how many will be consumed in the testing, how many consumed in the assembly. So one is testing 5,000, assembly is 3,000. So that is exactly the value we observe in the B18 and the B19. Okay. Now, important thing in this constraint table is the shadow price. So as we can see, testing shadow price is $114.28 something, and for the assembly capacity, its shadow price is $57.14 something. Okay, all right. Now, this means if you increase or decrease the one of the capacity, then what is the profit you are going to see increased? The optimal profit will be increased by shadow price. If you increase 1 hour of resource, or it will decrease by shadow price if you decrease 1 hour of resource. Okay, now so constrained right hand side 5,000, 3,000. So basically you can see those two is binding. Okay, when they are binding, then you will see shadow price not equal to 0. If they are not binding, so final value is not equal to the constraints right hand side, then you must expect shadow price to be 0. Now, what is allowable increase and allowable decrease? This is exactly what we show in the graphic approach. We say shadow price will change. So if you only change your constrained constant, for instance, for the testing, if you change it, this 5,000 within a certain range, shadow price remains. But if you out of that range, shadow price is going to be changed. So this 4,000 means you can, if you increase, you can increase at most 4,000. If you decrease, you can decrease at most 1,250. So I will post those what I have explained in this two text box for you for your reference in the future. So basically, it's explained what the shadow price means to the optimal profit. And also, it's also explained what is the allowable increase and allowable decrease means to the changing in the shadow price.